Alright, so we are on target 5D. This is day 1, and we are identifying variables and quantities needed to model problems and graph the equations. So learning goals. I can identify the dependent variables given a real-world problem, choose the appropriate scaling for the axes of a graph given a real-world scenario, and identify the variables and quantities in a real-world scenario that would allow me to create an equation. Sounds like a lot. It's really not that bad though. Okay, starting off, let's talk about independent versus dependent variables. So in all of these cases, your independent variable is going to be whatever's on your x-axis. Your dependent variable is always going to be what's on your y-axis. So your dependent variable depends on something in the independent variable. Like if we look at this first graph, time in minutes. As the time increases, a greater portion of students are able to locate suitable materials for the class. We look at this table, as the temperature increases, so we look at like 91, 85, those are the higher end ones. The higher the temperature, the greater the ice cream sales. The lower the temperature, the lower the ice cream sales. Alright, in all of these cases, the independent variable influenced the change in the dependent variable. Alright, so we take a look at this first example. So your history teacher is determining how much to save in order to buy all of the class's pizza to celebrate the end of the year. So which of the following variables could represent the dependent variable on the graph? So we've got pizzas, students, and cost. So thinking about independent variables, these can't change. Alright, so number of students, could that change? No, that's pretty much like, yeah, whatever students you have is what you have. Same with pizzas. However, the dependent variable is dependent on the number of students or the number of pizzas ordered. So in this case would be the cost, because the number of pizzas doesn't depend on the cost. The number of students doesn't depend on the cost. But the cost does depend on how many pizzas you order, how many students you have. Those are all things that could influence or change the cost. If you're only going to order one pizza, the cost will be lower. If you're going to order 10 pizzas, the cost is going to be higher. So that's dependent on how many of either A or B, depending on what you wanted to use for your graph, would be. Next example. Suppose you wanted to graph B equals negative 50M plus 800. It shows a bank account balance each month beginning with January. Okay, B represents the total amount of money in the account in dollars. So that's B. B, total amount of the money in the account in dollars. M represents each month starting with January. Since B depends on M, the vertical axis is going to be the B axis, and the horizontal axis will be the M axis. So given that, and given the scale on the horizontal axis, so what we know is January, February, March, April, May, so these are the months, we want to choose an appropriate scale for the vertical axis. So what we want to do is we want to look at our equation. And we've got 800 as our starting point. So we know that this has to be 800 right here. So we'll go ahead and put that in. We also know it goes down by $50 every month, which would mean that this right here, 50 less than 800 would be 750. In February, 50 less than that would be 700. And keep going until you find something that actually makes sense. Like here, our next grid line, we don't get to until 600, which is April. So we would make that 600. And now that we have this, when you have a graph, that each grid line has to be the same difference. So since we have a $200 difference here, we can actually fill in the rest, and therefore determine that the scale will be by 200s, because there's a $200 change. So this is 0, this is plus 200, plus 200, plus 200. So the scale is by 200s. Third and final example. Suppose your school is having a battle of the bands to raise money. You think that 75 students and 50 adults will attend. It's going to cost $250 to put on the show, and you want to raise $900. So if you have the following choices, you want to identify the variables and the quantities that you would need to create an equation that can be graphed. So we want this to be accurate. So your variables are going to be the number of students and the number of adults. So we would call that S, which would be the cost of a student ticket, and A, which would be the cost of an adult ticket. Because we think that 75 students and 50 adults are going to be there. So if we want to raise 900, we have to figure out what we're going to charge for it. So there's our 75, which would be one quantity. 50 would be another. 250 is what it's going to cost us to actually put on the show. So that's something that has to be factored in. We want to raise $900. So in order to do that, we want to also figure out what the amount we would need to raise total, or the amount we so that we could cover the cost of the show and hit our goal of $900. So we would want to raise $900 with an upfront cost of $250. So you have to basically make $1,150 to make back that cost and raise the money that you want to spend. So this part is actually not too bad, the 250 plus 900. So that's those two. The hard part is going to be coming up with this and then figuring out what your variables are going to be. And that's it. We have one more video this semester, guys. I know you can do it. Finish the year strong, and second semester will be right around the corner before you know it.